Welcome back. We are continuing talking about absolute value today, looking at inequalities this time. So first, quick refresher on what our different inequalities mean. If I wanted to sketch a graph that satisfies x is between -2 and 5 on my number line, I'm going to start with 0, go backwards, here's -2, and here's 5. So because x is going to be between those two numbers, I'm going to do two open circles because my inequalities are not underlined. And I'm going to include everything in between them. Similarly, over here, x is greater than or equal to 4, or x is less than or equal to 4, or x is greater than 7. I'm going to start with 4 and make sure both of those are on my number line. This one's going to be a closed circle with an arrow going to the left. This one's going to be an open circle with an arrow going to the right. So just a refresher on how we graph those inequalities, and you're going to need to know that to graph your solutions to these absolute value problems we're looking at today. So when we say that the absolute value of a number is less than a, that means it is closer than that to 0. So it's going to be between the negative and the positive of whatever that a value is. So for example, if x is less than 2, the absolute value of x is less than 2, that means that it has to be between 2 and -2, because all of those numbers are less than 2 away from 0 on my number line. And so that would be how I would graph that. If the absolute value of x is greater than a, that means it is farther away from 0 than those two solutions. So it's going to be all of the numbers that are less than -a or greater than +a. So conversely to the one we did above, if x is going to be greater than 2, then that means, again, I'm going to be looking at 2 and -2, but x will be less than -2, so open circle, arrow to the left, or x is greater than 2, open circle, arrow going to the right. So what happens when you don't immediately know what x is greater than or less than, like you have an equation? Well, let's look at it. Starting with example 1, if the absolute value of x minus 5 has to be less than 2, that means that x minus 5 has to be less than +2 but greater than -2. Those numbers have to be less than 2 away from 0. So this is now my inequality. I'm going to solve for x. We do this similarly to equations. Whatever you do in the middle, you have to do on the left and on the right. So if I add 5 to all sides, this is going to become 3. This becomes x, and this becomes 7. So now to graph that on my number line, I would need to make sure I have 3 and 7, and it's going to be two open circles and a line between them. On the next one, the absolute value of 3x minus 4 is greater than or equal to 5. This is where I'm going to have two parts. 3x minus 4 needs to be greater than or equal to 5, or 3x minus 4 needs to be less than or equal to -5. So I have two individual inequalities to solve here by adding 5 and then dividing by 3. So x has to be greater than or equal to 3, or when I add 5 over here, add 4 over here, I get -1, and when I divide, x has to be less than or equal to -1/3. So I'm still going to put 0 and 3, so it's going to be greater than or equal to 3, or less than or equal to -1/3. I'm going to eyeball where that is. They both get closed circles because my inequality is underlined, and then we have arrows going in both directions. Moving on to example 3, again, my absolute value is not by itself, so first I have to divide both sides by 2. So the absolute value of x plus 4 is going to be greater than 4. Again, greater than implies two intervals. I need x plus 4 to be greater than 4, or x plus 4 to be less than -4. These are both just one steps. X is going to be greater than 0 when I subtract 4 over here, or x is going to be less than -8 when I subtract 4 on this side. So I'm going to start with 0, 1, 2, 3, 4, 5, 6, 7, 8, and -8. So x has to be greater than 0, open circle, or x has to be less than -8, also open circle. Moving on to 4, again, my absolute value needs to be alone firstly, so absolute value of 12x plus 5 has to be greater than or equal to 9. This again indicates two intervals. So 12x plus 5 has to be greater than or equal to 9, or 12x plus 5 has to be less than or equal to negative 9. 2 steps to solve, subtract the 5, and then divide by 12. So on this side, x is greater than or equal to 1/3. On the other side, I'm going to subtract the 5 and divide by 12. And on that one, x is going to be less than or equal to negative 7/6. So I've got two fractions, and I'm just going to try to eyeball them, starting with 0, x is greater than or equal to 1/3. So there that is, and then x is less than or equal to negative 7/6. I'm just going to eyeball that. And they both get closed circles because my inequalities are underlined. And then our final example, example 5. Firstly, I need to get my absolute value alone, but thinking of order of operations, I've got the 5 and the negative 7 that need to go. The 7 has to move first. So 5 times the absolute value of 4x plus 18 is going to be less than or equal to 5. Then I can divide both sides by 5. Absolute value of 4x plus 18 is going to be less than or equal to 1. The less than implies it's going to be one inequality, so 4x plus 18 has to be less than or equal to 1 and greater than or equal to negative 1. So solving this, whatever I do in the middle, I have to do on the left and on the right. So negative 19, now I've got 4x, and negative 17. Then I can divide everything by 4, and it's not going to be super pretty numbers. It's going to be ugly fractions. Negative 19 over 4, x is now alone, and negative 17 over 4. So they're both negative. So if I let this be 0 here, both of those numbers are greater than 1. Let me see about what they are. This one is going to be negative 4.75, and this one is 4.25. So if we go 1, 2, 3, 4, this is negative 4, this is negative 5. They're both going to be around here. So two closed circles, line connecting them, and there they are. Okay, that concludes our notes on absolute value inequalities.